All right, for practice 10.1, we are going to do problems 1 through 6 here. So this first one tells us the price of green beans at a supermarket is shown below in the table. Write an equation. So we need that equal sign for the total cost C in dollars. So our cost is money, P is pounds. So we're trying to figure out this pattern of how we're getting from one to the other here. So our first one, so we're trying to figure out how am I getting from P to C? And every time that has to be the same thing. So we have 80 cents and we're trying to get to $2.40. So how many of these make the total? So, right, I'm buying a pound. So if I buy 2 pounds, that gets me to $1.60. So we still need more. So if I buy another pound, there is 4 and 2, $2.40. So we bought 1 pound, 2 pounds, 3 pounds. So if I times this and buy 3 pounds, so I guess pounds, yes, is 3. And I get 0.8 of those. That cost me $2.40. So if I buy 3 of these, let's double check that it's going to work. So if I take 1.2 and I times it by 3, there's 6. 3 times 1 is 3 with a decimal place, $3.60. So every time we have this number, we are timesing it by 3. We're getting 3 times bigger. So we want 3 of these P's. So whatever this number is, it doesn't matter. We could pick any number to go here. These are P. 3 of the P's, so 3 P's equal the cost is C. So these numbers here are just helping us figure out how are we getting from here to here, here to here, and then we're plugging in the variable. Oh, we know the pattern was times 3, so we need 3 times P equals the C. So here's our independent variable. I get to choose how many pounds I'm going to buy, but this will be the total cost. Hey, number 2, joules and calories are 2 different units of energy. The equation stands J equals 0.239 C, right? So these are stuck together. We're timesing. Relates the measures where C is calories, J stands for joules. Complete the table. So we need to use this equation here to fill it in. So all of these, we know what C is. So if I plug this in, I just need to take 0.239 and I'm going to times it by C, which is 3, and that will tell me what J equals. So all we're doing is substituting in and we get that answer back. So this is independent. They can choose how many calories they have, but then the joules will depend on how many calories there were. So 3 times 9 is 27. 3 times 3 is 9, 10, 11. 6 plus 1 is 7, and I have 1, 2, 3 decimal places. 1, 2, 3. So this one is 0.717. So I'm going to let you finish the rest of this chart with the math. So this one, we need to take 0.239 and times by 7. Move your decimal 3 places when you're done. Just put your answer there. So this one, 0.239, we're going to times by 10. Again, move our decimal 3 places. Put our answer here. And then this time we have 50 calories, 0.239 times 50. Move our decimal 3 places when we're done is that answer. So I'm going to let you finish those 3 math problems to get those 3 answers. Okay, number 3 says a car wash attendant counted the number of cars washed and the total amount of money earned. The company charged the same price for each car washed and earned $165 for 15 cars, 231 for 21 cars, and 275 for 25 cars. So we can see all of this here. Write an equation for the relationship between the number of cars washed and the dollars earned M. So they washed 15 cars and made 165 dollars. They washed 21, right? And we know they're doing it over and over for each car. So we need to see how many times 15 can go into 165. And that will tell us our pattern that we're doing for one car, right? Because it says they charge the same price for every car over and over again. So we need to take 165 and we need to divide by 15. So I need something above the 1, the 6, and the 5. So it can't go into 1, but it goes into 16 one time. So there's 15, 1 left over. 15 goes into 15 one time. So each of these we are timesing by 11. So 21 times that they washed $11 per car. They washed 21 cars, $231. $11 per car. They wash 25. They make $275. So every time our pattern was to times by 11. So however many cars they wash, no matter what, we're going to take 11 and times it by the number of cars they washed. And that's going to tell us how much money they earned. So if they washed 300 cars, 11 times 300 will equal the money that they made. So no matter what N is, right, we just plug it in. The number of cars we times by 11 per car makes us the money. So the cars come and get washed, and that's independent. These people choose to come get their cars washed, but the number of money we make depends on, so this is dependent, the money we make depends on how many cars get washed. Hey, number 4 says the data for the fastest long distance train in the United States as of 2018 are shown, where T is the time in minutes and D is the distance in miles. So here's our thing. So every time we have a minute, it's going 2.5. And then we can see how fast it's gone after that. So if it goes 1 minute, right, it's gone 2.5. If it's gone 2 minutes, it's gone 5, and so on. If it's gone 10, it's gone 25. So we can see that same thing is happening over and over again. So what is dependent and what is independent? So I always like to start with the independent one. It's the one connected to the variable, the coefficient. So, or the coefficients connected to the independent variable. So the time, the train gets to decide how many minutes it's going to continue traveling. So the independent one is T, but the distance is going to depend on how long the train traveled. So it gets to choose how many minutes it's going to go for, but the distance will depend on how long the train went. It depends on that. Okay, so now we're going to use this to complete the table. So we have 2.5 and T, we're plugging in T times T. So we need to times T to get that first one. And I'm going to let you do that math there and plug it in. Okay, our next one, 2.5 times 10. So 2.5, it went for 10 minutes. So we times those together to see the distance that it goes. That's right. This one goes here. This one goes here. So now these ones are working backwards. We have 15 and it equals 2.5 T. We're trying to get T all by itself. So these are times together. They're stuck together. So the opposite is divide by 2.5. And if I divide by 2.5 on this side, I also have to divide by 2.5 over here. So we are going to set up our problem. So we have 15 divided by 2.5. So we want to move that decimal, but if I move it here, I have to move it here, right? That rule of math. If we do it to one, we have to do it to the other. So 25s is quarters, 25, 50, 75, 100. So I need something above the 1, the 5, 0. So it can't go into 1, can't go into 15. So we just need to see how many quarters make $1.50. So we have 25, 50, 75, 100, 125, 150. So this goes in there exactly 6 times. So if they've gone for 6 minutes, they'll have traveled 15 miles. So that's pretty quick. 6 minutes, 15 miles. Okay, our last one gets us 28 miles. So let's set up our problem. So we know 28 equals 2.5 for the minutes. We're trying to find the t. How many minutes did it travel to get 28 miles? So these are times together, so we have to undo it. We have to divide and divide. So this side cancels out. So we are going to do, oh, I gotta sneeze, 28 and divide by 2.5. I just like need to look into this light here, get my sneeze to go away. So if I move my decimal here, we have to move our decimal here. So now we're doing 280 divided by 25. So I need something above the 2, the 8, and the 0. So 25 can't go into 2, but it goes into 28 one time. So 25, and then we have 30 left over. So 25 into 30 goes there one time, which is 25, and there's 5 left over. So we're going to add a decimal and see what happens if I bring down a 5. Oh, 2 25s makes 50, so this is 0.2. So 11.2 here. So we either multiplied this way or we divided to work backwards following that same pattern every time. Okay, and our last ones, we are writing the equation to represent it. So we're looking for the pattern. How do I get from here to here, here to here, here to here? So we're starting with 17, and we need to get to 25. If I times 17 by anything, it's not going to make 25 nicely. So I'm thinking we've got to get bigger, but multiplying's probably not going to work. So let's try adding. How do I get from 17 to 25? So we're at 17, 18, 19, 20, 21, 22, 23, 24, 25. So there's 8 more. So let's see if I add 8 here. 17 plus 8 is 25. So let's try 14 plus 8. So we're at 14, 15, 16, 17, 18, 19, 20, 21, 22. 8 more does make 22. Let's just double check our last one. We want the pattern to work every time. So we're at 29, 30, 31, 32, 33, 34, 35, 36, 37, 30, right? We added on 8 and got 37. So the pattern that we followed every time was to add 8. So no matter what this is, right? It's X. I can put in any number. So I'm going to start with X. And what did we do? We added 8, and that equals the Y. So we're just using these numbers to find the pattern. We do it to the first one, and it equals the second one. So let's try out this one. So how do I get from 9 to 35? So I could subtract. Let's see. So 35 minus 9. So here is 2 and 5 makes 6. So that's 126. Did we add 126? Well, if I take 12 and add, let's say 126 plus 12, that equals 138. So we're not adding 126. That did not work. So we've got to get bigger. So our other choice is to multiply. So we need to know how many of these 9s to get to 135. So the opposite of multiply is divide. I'm going to work backwards and see how did I get there. So I need something above each of those. 9 can't go into 1. It goes into 13 one time. 4 left over, 45. Bring down the 5, goes in there 5 times. So this was times 15. So let's double check here. If I have 12 and I times 15, we should be getting 180 if that's our pattern. So 5 times 2 is 10, 5, 6, placeholder. 1 times 2 is 2, 1 times 1 is 1. So we have 0, 8, 1. Yes, so 12 times 15 is 180. And now let's just check if I do 15 times 16. So there's 30, 5, 6, 7, 8, placeholder, 6 times 1, 1 times 1. So we have 0, 14. So yes, 16 times 15 is 240. So we're taking our first variable, our independent one, and we're going to pick how many of these we want. So no matter what it is, how many of the D, we're going to times that by 15. That was our pattern. And once I do that, that's going to equal the second one, which is G. So the G's, how many G's we get, depends on how many of the D's that we wanted. D times 15 will equal the G. So we're just finding the pattern. Do it to the first variable and it equals the second one.